Today we're going to be talking about even and odd functions, meaning we are going to be looking at a function and trying to classify it and determine whether we think it is even, odd, or it could be neither. Do understand, do recognize that not every function is even or odd. You could have some functions that are just neither. So what we're going to do is we're going to run a test. We're going to run a couple tests on each function and see which one it passes, or maybe it doesn't pass either of them. We'll start talking about the even test. Okay, if a function is even, what that means is if you find f of negative x, it will be exactly the same as just f of x. Meaning, what we're going to do is we are going to take whatever function we've been given and we are going to plug negative x in for x. We're going to replace our input with its negative version. If, when we do that, when we replace the input with its negative version, if somehow we are still able to get it back to the original function, just the original f of x, well then this would be an even function. If that doesn't happen, then we will want to test and see if a function is odd. If the function is odd, we will still have plugged in f of negative x. Okay, so if a function is odd, we're still plugging the negative version of the input in. But this time, we don't want it to be the same as what we started with, the same as the original. Instead, we want it to be the same as negative f of x. Now, when we say negative f of x, basically what I'm meaning is take the entire function, the entire f of x function, and multiply it by negative 1, like as if you put parentheses around the whole thing and multiplied it by negative 1. If it doesn't pass that test, then we get to say it's neither. Let me show you what I mean by that with an example. So as you can see, we've been given functions here, and it's just asking us to determine if it's even, odd, or neither. So let's say I gave you the function g of x equals x to the third minus x. Well, to start off with, like we said, we're going to plug in negative x for x, meaning instead of x to the third, we would now have a negative x to the third. And now we'd be taking it minus a negative x instead of just x. That's what I mean by plugging negative x in for x. So now we want to try and simplify this down. I think the easy one is probably the one on the right there. If you have minus a negative x, that's certainly the same thing as just plus x, right? But the other thing you want to ask yourself is when we take negative x to the third, if we are taking a negative number to the third power, is that going to stay negative, or would it change to being a positive number? In this case, because we have an odd exponent, because it's to the third power, it would stay negative, right? Because if you think about taking negative x to the third power, that means you're taking negative x times negative x times negative x. Well, a negative times a negative would be positive, but then the positive x squared times this other negative x is going to flip it back to being a negative, right? Anytime it's an odd exponent, the sign will stay the same. So if it started out negative, then the odd exponent simply means it will stay negative. So this right here is what we have got from plugging in negative x. It's not our answer, but that's what we got when we simplified by plugging negative x in for x. So the first thing to test would be to see if it's the same thing as the original, to see if it's an even function. So is this, what we highlighted here, the same as what we got originally? This part right here. Well, obviously the answer is no, right? Those are not the same. Just visually you can see those are not the same. So even is off the table. This is not going to be an even function. We can throw that possibility out the window. Next, we need to check to see if it passes the test for odd. So we're still referring to what I've highlighted in yellow here, what we got from simplifying. But for the odd test, we don't want it to be exactly the same as the original. We want to take this original function, what we were given to begin with, and we want to multiply it by negative 1. Well, in this case, if we're taking -1 times that entire function, the x to the third minus x, that's a distributive property. So we'd take -1 times x to the third to give us negative x to the third, and -1 times negative x to give us a positive x. And now the question would be, looking at what we now have after taking the whole function times -1, does this match what we got from simplifying? Well, the answer this time is yes, they did match up. So it passes the odd test, and we would label this as an odd function. Let's look at another example. Let's say I gave you h of x equals x squared plus 1. Well, to do that, we'd want to do h of negative x. We want to plug in the negative version of the input. So instead of x squared, we would have negative x squared. The plus 1 would just be rewritten. That doesn't have an x, and I'm only plugging in negative x, so there is nowhere to plug anything in there. So we just rewrite it. So this time the question would be, what is a negative number squared? If we square a negative number, does it stay negative like in the last problem, or does it change to being positive? Well, we know that if you take a negative number times a negative number, a negative times a negative is a positive. And since squaring means you're taking something times itself, anytime you square a negative number, you will always get a positive answer, meaning we can change this back to a positive x squared. Well, in that case then, looking what we got from simplifying, that does perfectly match what we started with. So since it matches what we started with, this would actually pass the even test. It is an even function, which means we don't have to do the rest of our tests. It's even, we can move on. Let's do one more example. Let's say I gave you this function. F of t equals t squared plus t. We would want to do f of negative t. Don't be thrown off by the fact that it's t instead of x. T is our input. We just want to plug in the negative version of our input. So that would give us, instead of t squared, it'd be a negative t squared. And instead of being plus t, it'd be plus a negative t. If we want to simplify this, we just stated that any negative number squared becomes positive. So this would be a positive t squared. Also, plus a negative t is really the same thing as just saying minus t. That would be probably the most simplified way we could write this. Well, if we compare that to our original function, it's close, but it is not exactly the same. We started with t squared plus t, now we have t squared minus t. So this is not going to be an even function. It does not pass that. So just like the first example then, we want to put parentheses around the entire function, the entire f of t function, and we want to multiply by -1. Again, this would be a distributive property. So we'd take -1 times t squared to give us negative t squared, and we'd take -1 times positive t to get negative t. And then we'd want to compare this to what we got when we plugged in negative t. This time, even these do not match up. They are not the same thing. Recognize this negative t squared up here cannot be changed at all because the negative is not inside any parentheses. So since this does not match up either, this function is neither even or odd. That is an example of each different type you could have, and that is how you test to see if functions are even, odd, or neither.